Welcome to HNM Technologies online training. Let's start with a simple question. How is AI suddenly able to write code, generate images, answer questions, and even have conversations like humans? That's where generative AI comes in. What is generative AI? Generative AI is a type of artificial intelligence that can generate text, create images, compose music, write code, even simulate conversations. Unlike traditional AI, which classifies or predicts, generative AI creates new content. Examples you already know: chatbots like ChatGPT, AI image tools, code assistants, AI voice generators. Key idea: traditional ML equals predict, generative AI equals create. To understand generative AI, we need to see how we got here. Artificial intelligence. Goal: to make machines intelligent. For examples: rule-based systems, chess-playing programs. Machine learning. Machines learn from data instead of rules. Examples: spam detection, recommendation systems. Deep learning. Uses neural networks with many layers. For examples: image recognition, speech recognition. Generative AI. Models that generate new data. Examples: text generation, image generation, code generation. Key insight of generative AI is powered by deep learning models trained on massive data. Now we come to the core. Definition of LLM. LLMs are deep learning models trained on huge amounts of text data to understand and generate human language. Why large? Because billions of parameters, trained on massive datasets, require huge compute. What can LLMs do? Answer questions, translate languages, summarize text, write code, chat like humans. Simple analogy: think of LLM as a super-powered autocomplete system. But instead of "Hello, how are you?" it can generate entire paragraphs. How LLMs work? Let's simplify this. Step 1. Tokenization. Text is broken into small pieces called tokens. For example, machine learning is powerful becomes machine learning is powerful. Step 2. Predict next token. The model learns. Given previous words, what is the next word? Here is the example. I am going to the possible outputs. Market school office. Step 3. Probability. The model assigns probabilities. Market 60%, school 30%, office 10%. Then it moved to step 4. Generate output. It picks the most likely, or sampled, word. The important insight: LLMs do not think like humans. They predict based on patterns in data. Transformers are the core technology behind modern generative AI and LLMs, and understanding them gives you a huge advantage. Before transformers, models like RNNs and LSTMs processed text sequentially, meaning they read one word at a time. This made them slow and inefficient, especially for long sentences, and they struggled to remember long-term dependencies. Transformers solved this by introducing a parallel processing mechanism, allowing the model to look at the entire sentence at once. The most important concept in transformers is self-attention. Instead of treating words independently, the model evaluates how each word relates to every other word in the sentence. For example, in the sentence, "The cat sat on the mat because it was tired," the model understands that it refers to cat using attention. Another key idea is multi-head attention, where the model looks at relationships from multiple perspectives simultaneously. One head might focus on grammar, another on meaning, another on context. This improves understanding significantly. Transformers also use positional encoding, because unlike sequential models, they don't inherently know word order. Positional encoding injects information about the position of words in the sentence. The architecture typically consists of input embeddings, attention layers, feed-forward neural networks. Transformers scale extremely well, which is why models today have billions of parameters. This scalability is what enabled the rise of powerful models like GPT. In simple terms, transformers equals attention plus parallel processing plus scalability. Training a large language model is a multi-stage, highly resource-intensive process that involves learning patterns from massive datasets. The first stage is called pre-training, where the model is exposed to huge amounts of text data such as books, articles, websites, and code repositories. The goal during pre-training is simple: predict the next word, token, in a sequence. Through this process, the model learns grammar, facts, reasoning patterns, and even coding structures, not explicitly, but through statistical relationships. This stage alone can take weeks or months and requires powerful GPUs or TPUs. After pre-training, the model moves to fine-tuning, where it is trained on more specific datasets to improve performance in certain tasks like conversation, summarization, or coding. Fine-tuning helps make the model more useful and targeted. A very important step in modern LLMs is reinforcement learning with human feedback, RLHF. In this process, humans evaluate multiple model responses and rank them. The model then learns which type of answers are preferred, making it more aligned with human expectations. Training also involves loss functions, which measure how wrong the model's predictions are, and optimization algorithms that adjust parameters to reduce error. Another important concept is overfitting versus generalization. A good model should generalize well to unseen data, not just memorize training data. Final takeaway. Training an LLM equals learning patterns plus refining behavior plus aligning with humans. Generative AI is not limited to one domain. It is transforming multiple industries by acting as a content and productivity engine. One of the most common applications is text generation, where AI can write blogs, emails, reports, and even books. This is widely used in marketing and content creation. In software development, generative AI assists developers by generating code, suggesting improvements, debugging errors, and even explaining complex logic. This significantly speeds up development time. Another major application is customer support, where AI-powered chatbots can handle queries 24/7, reducing human workload and improving response time. In education, generative AI acts as a personal tutor. It can explain concepts, generate practice questions, and adapt explanations based on the learner's level. In the business world, it is used for report generation, summarizing large documents, analyzing data, and automating workflows. Generative AI is also used in creative fields, including image generation, video creation, music composition, and design. In healthcare, it helps in documentation, research summarization, and even assisting doctors with insights. The key insight for generative AI is not replacing jobs, it is augmenting human capability and boosting productivity. Prompt engineering is the skill of designing inputs to get the best possible outputs from an LLM. Since LLMs rely entirely on the input prompt, the quality of the response is directly influenced by how well the prompt is structured. A vague prompt like, "Explain AI," may produce a generic answer, while a detailed prompt like, "Explain AI in simple terms with real-world examples for beginners," produces a much better result. There are several prompting techniques. Zero-shot prompting means asking directly without examples. Few-shot prompting includes examples in the prompt to guide the model. Chain-of-thought prompting encourages the model to explain step-by-step reasoning, which improves accuracy in complex problems. Another powerful technique is role-based prompting, where you assign a role to the model, such as, act as a senior software engineer, or act as a teacher. This helps control tone and depth. Providing constraints and format instructions also improves output. For example, give answer in bullet points, or limit to 5 lines. Prompt engineering is becoming a key skill because it allows users to control AI behavior without changing the model itself. The key takeaway: better prompts equals better, more accurate, and more useful outputs. Despite their power, LLMs have several important limitations that users must understand. One major issue is hallucination, where the model generates incorrect or fabricated information with high confidence. This happens because the model predicts likely text, not verified facts. Another limitation is bias, which comes from the data the model was trained on. If the training data contains biases, the model may reflect them in its responses. LLMs also lack true understanding or consciousness. They do not know things, they simulate knowledge based on patterns. There are also security risks, such as prompt injection attacks, where malicious inputs can manipulate the model's behavior. LLMs can struggle with real-time or up-to-date information, especially if they are not connected to external data sources. Another concern is cost, as training and running large models requires significant computational resources. They also have context limitations, meaning they can only consider a limited amount of text at once. One important message: LLMs are powerful tools, but they require human supervision and critical thinking. The future of generative AI is incredibly exciting and is expected to reshape how humans interact with technology. One major trend is multimodal AI, where models can understand and generate not just text, but also images, audio, and video. This will enable more natural and powerful interactions. Another emerging concept is AI agents, which are systems that can plan tasks, make decisions, and execute actions autonomously using tools and APIs. We are also moving toward personal AI assistants, which can help individuals with daily tasks such as scheduling, coding, learning, and decision-making. In industries like healthcare, finance, and education, AI will play a major role in improving efficiency and accessibility. Developers will increasingly use AI as a co-pilot, writing code faster and solving problems more efficiently. However, this also means that skills will shift, understanding AI and working with it will become essential. Ethical considerations and regulations will also become more important as AI adoption grows. The final insight: the future is not about humans versus AI. It is about humans who use AI versus those who don't. What we covered: Introduction to Generative AI, Evolution from AI to ML to Deep Learning to Generative AI, Understanding Large Language Models, LLMs, How LLMs Work, Tokens, Predictions, Context, Transformers and Attention Mechanism, Training Process, Pre-training, Fine-tuning, RLHF, Real-world applications of generative AI, Importance of prompt engineering, Limitations of LLMs, Future of AI and generative technologies. Key takeaway: don't just use AI, understand how it works. Learn it, apply it, and stay ahead in your career. Thank you for choosing HNM Technologies online training. Keep learning with us. Subscribe for more valuable content.